Assalamualaikum and welcome everyone. My name is Muhammad Irfan Ardiansyah, and today we will going to talk about operating system process management. So from the begin, let's start with the big picture about the basic element of modern computing. So every computing system relies on its architecture. So the hardware components like the processor, memory, and I/O devices that drive its operation. The operating system oversees the orchestration of these resources, so it's will managing everything from process scheduling to memory allocation and device coordination. So in here, operating system also provide abstraction layer that it will simplifying complex operation into user-friendly interfaces. So through system calls, user can interact with the operating system and requesting essential services for their application. And in additionally, the design of operating system kernel is crucial with four main architectures. The first is monolithic, microkernel, modular, and exokernel. So today our focus shifts to process management within the operating system. In here, a process serves as the fundamental unit of execution within the system. But how exactly are processes represented in the operating system? And what are the states? And how does the system facilitate the movement of a process from one state into the another state? And ever you wondered how processes are created within the system? And you know that communication between processes is essential for collaborative computing, but is this communication efficient? So, for the understanding about this question, for the first step, let's understand the anatomy of a process within the operating system. So, a process is the dynamic execution context of a running program. It encapsulated all the necessary information for the program to execute, including its code, data, and execution state. So, it's important to note that several processes might run the same program, but each process is distinct with its own state. For example, multiple instances of a word process like Microsoft Word might be running simultaneously, but each with its own set of data and execution state. So in here, at its core, a process executes sequentially one instruction at one time. The sequential execution is managed by the operating system to ensure proper flow and synchronization. And the state of process consists of several essential components. The first is the code for running program, static data that associated with the program, a pointer that space for dynamic data, the program counter that indicating the next instruction to be executed, and stack pointer that an execution stack that maintains the program call chain, and values of CPU registers that storing important execution context, and a set of OS resources such as open files or allocated memory, the resources that used in this process, and the process execution state for the example as ready, running, waiting, and etc. Okay, here is the different state within the operating system. So the first is when a process in the new state, the operating system is setting up its initial state. So this includes allocating necessary resources and initializing data structures. So the next, in the running state, the processes is actively executing instruction on the CPU. So this is where the bulk of the program's computation takes place. So next, on the ready state, it is are prepared to execute, but they are waiting for their turn to run on the CPU. So this often occurs when multiple processes are competing for CPU time. And when a process is in the waiting state, it's waiting for a particular event to occur, such as input or output operation, to complete or signal from other processes. So for the last indeterminate state, the processes has completed its execution and the operating system is in the process of cleaning up resources associated with the process. Okay, in here, PCB is an OS managed data structure designed to keep track of all processes within the system. So it serves as a repository of essential information about its process and facilitating efficient management and scheduling. So what is the content of PCB? The first is process state that indicated the current execution state of the process, for the example running, waiting, and etc. And then process number, its unique identifier assigned to each process by the operating system, and program counter that store the address of the next instruction to be executed by the process, and then stack pointer, the point to the top of the execution stack for the process, and general purpose register that stores the values of CPU registers associated with the process, and memory management information that contains detail about the process's memory allocation and usage, and username of owner that identifies the user who owns the process, and list of open files that tracks the files opened by the process during its execution, and Q pointer, it's a pointer that used by the operating system to place the PCB in various task queues, for example in ready queue, waiting queue, and etc. And the next, scheduling information that includes parameters such as priority that influence the process scheduling and execution, and about IO status that indicates the current status of IO operation associated with the process. And in here about the PCB life cycle, that the OS allocated a new PCB for its processes upon its creation, populating it with relevant information. So during the process execution, the PCB is updated to reflect change in its state and execution context. So when the process terminates, the OS deallocated the PCB and reclaiming the resources associated with it. So in here, within the integrated framework of process management, the operating system organized processes using state queue that we was talked before. Okay, the operating system maintains the process control blocks or PCB of all processes in the state queue. So these queues serves as repositories for PCB and categorizing processes based on their execution state. So in here, processes in the same execution state are placed in the same queue. So this organization enables the operating system to efficiently manage process with similar behavior and requirements. So when the operating system change the state of a process, it unlink the PCB from its current queue and moves into the appropriate state queue. This is the dynamic movement, ensure the processes are consistently managed and scheduled based on their current requirements. So when the operating system can employ various policy to manage each queue effectively. These policies dictate how processes are selected for execution, prioritized, and scheduled within their respective queue. And in addition to process state queues, each IO devices has its own wait queue. So processes waiting for IO operation to complete are placed in this device specific queues. So it's allowing the operating system to manage device access and resources utilization efficiently. Okay, in here, transitioning between processes involves a fundamental operation known as a context switch. So, for the definition, starting and stopping processes entails a context switch, which is a relatively resource intensive operation. So, when the operating system initiates the execution of a ready process, it loads hardware registers such as the program counter or PC and stack pointer or SP from its corresponding PCB. So while a process is running, the CPU continuously modify register such as the program counter and stack pointer to manage execution flow. So when the operating system halt a process, it preserves the current value of register by storing them back into the process PCB. And the act of switching the CPU from one process into the another process and involve stopping one process and initiating the execution of the next and constitute a context switch. In time sharing system, hundreds to thousands of context switch might occur per second. So in here, the cost of context switch and the time interval between switches are closely related. So efficient management of context switch is crucial for system performance and responsiveness. Okay, in here, the creation of new processes play a crucial role in distributing workload and executing tasks efficiently. So, a process can generate other processes to perform tasks. So, the process initiating the creation is termed the parent, while the newly created process is referred to as the child. The parent typically delegates resources and privilege to its child processes. So, parents define or allocate resources and privilege to their children and enabling them to operate within the system. So, this transfer of resources facilitates collaborative computing and task delegation. And in here, parents might choose to either wait for the child process to complete their task before continuing, or they may continue their own execution in parallel with their children. So, for the example, in Unix like operating system, the fork system call is employed to create child process. So fork duplicates variable and register from the parent to the child. So the only difference between the child and the parent lies in the return value of the fork call is in the parent process, fork returns the process ID of the child, and in the child process the return value is 0. So and here parents can opt to wait for the child processes to terminate by executing the wait system call, or continue their execution independently. So in here, child process often commence their own unique task or execute different programs within themselves, typically initiated by the exec system called. So let's we illustrate the process creation mechanism with a practical example in a unique based system. So when you log in to a machine running Unix, you initiate a shell process. So this shell serves as your command interpreter that facilitating interaction with the operating system. And every command you enter into the shell spawn a child process of your cells. So this process creation follows an implicit fork and execution pair. So for instance, when you type Emacs into the cell, the operating system fork a new process and creating a child of your cell, and then execute Emacs within this new process. So if you open an AND after a command, Unix executes the process in parallel with your cells. This means that your cells can continue to accept and execute commands without waiting for the current process to complete. And conversely, if you don't include an AND after a command, Unix execute the process sequentially. This means that your cell waits for the current process to complete before proceeding to execute the next command. So let's dissect an example Unix program and understand the functionalities of its key component. So fork, the fork system call created a new child process that is an exact copy of the parent process. So this allows for parallel execution of tasks that with each process having its own memory space and execution context. So the X function, XCLP function, replace the program of the current process with the name of program. So it's commonly used to execute external programs within a process and effectively transitioning the process to a new executable image. And then the sleep function suspend the execution of the current process for at least the specified time and allowing for time-based delays or scheduling within the program. And the white PID function allows a process to wait for the termination of a specific child process. So it enables synchronization and coordination between parent and child process and ensuring proper sequencing of tasks. And the last about the get function reads a line from a file that typically used for input operation within the program. So it facilitates user interaction and data retrieval from external resources. Okay, in the life cycle of a process, termination marks the end of its execution. So upon process termination, the operating system reclaims all resources allocated to the process. This includes memory, CPU time, and other system resources utilized during the process execution. So in here, Unix termination mechanism have the two termination. The first is self-termination. So it is a process can voluntarily terminate itself using the exit system calls. So this allows processes to get gracefully exit and release resources back to the system. And the second termination is termination of child processes. So In Unix like operating system, a process can terminate its child processes using the kill system calls. This provides a mean for parent processes to manage the life cycle of their children and enforce termination when necessary. Okay, in here, processes can either operate independently or cooperate with each other to achieve common goals. So, the first we will going to talk about cooperation versus independence. So, processes can be categorized as either independent or cooperating, while independent process operate in isolation, and cooperating processes collaborate to accomplish certain objectives. And what the benefit of cooperation? The first is performance improvement. So, cooperating process can enhance system performance by overlapping activities or execution tasks in the parallel. This allow for efficient resource utilization and faster task completion. The second is program structure enhancement. So, structuring an application as a set of cooperating process offer advantage over a monolithic program. So each process can focus on a specific aspect of the task and resulting in a more modular and maintainable program structure. And the third is information sharing. The cooperating process facilitates seamless sharing of information between tasks. So this enables data exchange and communication, fostering coordination and collaborating among different components of the system. Okay, in here, in distributed system, communication often occurs through message passing. So what is the message passing? We know the distributed system typically rely on message passing for inter-process communication. This involves sending and receiving message between processes to exchange information and coordinate activities. So, in message passing, each process need to be able to identify the recipient process. This ensure that message are delivered to the intended destination. And in here, message passing assume that the consumer process has an infinite buffer size to accommodate incoming messages. However, if a bounded buffer is used, additional checks and communication of buffer status may be required between the producer and consumer processes. So the operating system in here plays a vital role in managing message passing. So it handles tasks such as copying messages, notifying receiving processes, and ensuring reliable delivery. Okay, in some scenarios, inter-processes communication or IPC can be facilitated through shared memory. So, shared memory communication involves establishing a mapping between the address spaces of multiple processes to a named memory object. So this memory object can then be accessed and modified by these processes and enabling data sharing. So and then the mmap function system calls in here is commonly used to establish this mapping between the process address space and the shared memory object. So it's allow processes to map region of a file or other memory object into their address spaces. Okay, in here, processes that need to share the data structures contained in shared memory can be forked from a parent process. So this allow multiple processes to access and manipulate the shared data and facilitating communication and collaboration. So in here, utilizing shared memory for communication have the advantages such as fast data access and efficient sharing of large data structure. But however, it also requires careful synchronization mechanism to prevent race condition and ensure data integrity. Okay, for the last, let's recap the key point of the process management within the operating system. So we know that process serves as the fundamental unit of execution within the operating system that encapsulating a program codes, data, and execution context. So in here, processes are represented by PCB in the operating system. So PCB store the crucial information about each processes, including its state, scheduling detail, memory management information, and etc. And a process can exist in one several state, new new stats, ready stat, waiting stat, running stat, or terminated stat. So each stat reflect the current execution stage and behavior of the process within the system. Okay, for the example, on a uniprocessor system, only one process can be running at any given time. So the CPU execute processes sequentially and switching between them via context switches, and changing the currently execution process on the CPU involves performing a context switch. So this operation is relatively expensive and involves saving the state of the current processes and loading the state of the next processes. So for the last processes can communicate with each other using either message passing or shared memory mechanism. So message passing involves sending and receiving messages between processes, while shared memory allows process to access and modify shared data structures. Okay, I think it's enough for this material today about the operating system process management. I hope that this video is helpful for you all that want to learn more about the operating system. So maybe we can meet again in the next video. My name is Muhammad Irfan Ardiansyah. See you guys and assalamualaikum warahmatullahi wabarakatuh.